Hi, everybody. Dr. Lisa here. Apologize for the poor lighting in my office. Look, I'm in my office. So I wanted to say a word to you about the midterm exam. We talked about it in class today, but I know that many of you are not able to come to the class in person or even virtually. So I just wanted to give you a heads up what's going on. Something went wrong with the midterm. I'm not sure what happened. We talked about it in class, and it seems like perhaps one of the things that went wrong is that a lot of you were on this GroupMe chat that's going along, and perhaps the GroupMe was sort of the blind leading the blind, and nobody really knew what was going on, and therefore was not able to give good advice, because generally speaking, the whole class kind of tanked on the midterm. And so I don't see that as a failure of yours. I see it more as a failure of mine. But as a result, I'm going to ask you all to just redo the midterm. So just moments ago, I uploaded the Excel file that you had turned in for the midterm. I uploaded it onto Canvas with my comments, so you can see where you went wrong. And then I also wanted to make this video to explain to you, like, sort of what was going on with the midterm that I think you guys weren't getting. So I'm going to share my screen here. And here's the midterm exam. So this was a problem about partitioning in a bottle of salad dressing, just because that's a good example of a system with air, vinegar, which is you can treat as just water with salt in it, and some olive oil, so that's a great three-phase partitioning problem. And the trick here, this question I asked extra credit to anyone who could figure out why I chose these compounds. I'll now tell you the answer. The answer is I went to the back of the book and I looked at the appendix and I found chemicals that had a melting point between 3 and 25 degrees Celsius. And that was so that here I could say, in your, is your compound a solid, liquid, or gas? And hopefully you found that at 3 degrees Celsius, it was a solid, and that at 25 degrees Celsius, it was a liquid. I did that on purpose to make you think about that phase change. And it's so depending on where you went to get your equilibrium constants and stuff, like, for example, if you looked up your melting point on EpiWin, you might have gotten a very different number, and it might have been above 25 degrees C or below 3 degrees C. That's not your fault, and that's fine. I didn't take any points off for that, but that was sort of the point of the exam, is I wanted to give you chemicals, this whole list of chemicals for which the melting point is between 3 and 25 degrees C, so that you'd have to think about that phase change transition. So obviously here I'm asking you to look up all of your equilibrium constants and stuff. Note that on the LSER website, there is frequently, not always, but frequently, there is a delta H value for Henry's law for your chemical. So for example, here I downloaded the numbers for paraxylene, which is 1,4-dimethylbenzene, I think. Anyway, it's got an air-water bulk phase partitioning delta H prediction of 37.64, and it's in joules per mole Kelvin, or excuse me, joules per mole. So for many of your chemicals, this is available, right? And I have just added a new video to the Canvas site under modules, under the prediction thing, which is down here, week 9. I just added this new video over the break. Dr. Lisa explains how to use the UFZ LSER online tool that shows you how to get those delta H terms out of that tool. So that may help you on this midterm exam. And if you can find the delta H AW, and you can either estimate or find delta H of vaporization, HEW, the excess enthalpy for dissolution in water, is the difference of the two. And then HOW, you're probably just going to have to make an educated guess here and then explain your guess. I don't take points off for getting a bad number. I take points off for having a bad explanation and not understanding why. Okay, so hopefully, again, you found that your compound was a solid at 3 degrees C and a liquid at 25. So you need to calculate its solubility at 3 degrees C and assume that the vinegar is water with some salt in it. And I gave you salinity up here. I did the calculation for you. It's pretty salty, more salty than seawater. So many of you had problems with this part of the question as well. And so there's another video that I just made, and I put it under the solubility, aqueous solubility here. Practice problem calculating solubility across the melting point. Here's the Excel file, and here's the YouTube video. So that will help you with that part of the exam. So calculating the solubility there. And then here, the three-phase partitioning, you're asked to calculate the fraction in each of these three phases. Most of you use the right equations, but you forgot to correct your Henry's law constant and your KOW value for temperature and salinity, right? You have to do this at 3 degrees Celsius and assume that the vinegar is water with some salt in it. And again, it's a lot of salt. So you have to take that into account. That's where most of you went wrong. The three-phase partitioning was fine. You're able to do that, but you just used the wrong Henry's law constant and the wrong KOW. And then for this question here, I was trying to find a way to ask you a question that made you think about hydrogen bonding, van der Waals, and polarity forces. And in the past, I've done this via multiple choice type questions. And we have seen that you hate, students generally universally hate taking those multiple choice kind of tests online. They find it very stressful. They don't like the time component. So I thought that this was actually a pretty clever way to make you think about this issue and to give you, put some guardrails on it so you can't choose any chemical in the world. You have to choose one of the chemicals that's in the appendix. So I just want to point out that if you are going to this practice problem here and thinking, this is a good way, I can just look up the log KOW and the log KAW and tell what phase things are going to go in. I just want to point out that this is for very, very different volumes. Right? In our case, the volume, it was 100 liters or 100 milliliters, 100 here. The vinegar, the water is 150, and the air was 250. And when you do that way, you see this is very shifted. So there's only a tiny amount of things that are in the air. Most things end up in the octanol because there's so much octanol. And then you have to go to a log KOW of less than 1 to find things that are actually going to end up in the water phase. A low Henry's log constant and a low log KOW to put you down over here somewhere. So yeah, you can't just use this as it was given. If I undo here, you can't just use this as it was given because that's for a different set of volumes. Okay, and then graduate students, this is where I was asking you to think outside the box a little bit. You know that we use the Sessionow constant to correct things like Henry's law and KOW for salinity. And I gave you an equation to correct solubility for the volume fraction of co-solvent. You should be able to take that cognitive leap and say, I can correct KOW and Henry's law using those same equations. And then talk about it down here. So I hope that roadmap gives you a better idea of what you need to do to solve the exam. And again, I'm giving everybody until midnight or 11:59 p.m. on next Tuesday, which is the 29th, to redo your exam and turn it in. You can just take the file that I gave you on Canvas, download it, and you'll see my comments there. You can make the changes and then upload it back to Canvas. So I hope that will clear up any confusion about the midterm exam. I don't want you to feel bad or feel like a failure. Something collectively went wrong here. It was not any one individual. So don't feel bad. We're going to have a do-over. All right. Bye, everybody. I hope, if you have any questions, I know that there are many of you who are not attending class either in person or online because it doesn't work with your schedule. That's fine. If you have questions, email me. I have routinely found time to Zoom with people within 24 hours of them sending an email. I will get together with you one-on-one on Zoom and answer any questions you have because I want everybody to get an A in this class. That's my goal. I want everyone to learn the material and do well in this class. That's my job. It's what I do. So use me as a resource. I am here to help you. So ask me if you have any questions. All right. Hope you guys all had a good spring break. See you soon. Bye.